Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. I hope you guys are all having a wonderful day. Hey, Gibbous, and anyone who might be lurking in chat, hi. Thanks for being here. So today, we're taking a step back from the Becoming a Fractal saga and returning back to the Coding a Quilt saga, which we did a while ago, and we got most of the way through with it, implementing what you can see in the upper left-hand corner, which is color quantization, and then going from there. Might be just you for now, Gibbous, but other people will show up, I'm sure. I don't see too many viewers on. It looks like I only have a few viewers, so it's fine. Gonna lurk. Yeah, see ya, Gibbous. Have a wonderful time lurking. Anyway, let's go ahead and open up Zernal PP, and let's just talk for a bit. And then we'll hop into what we need to do for Quiltify. Hopefully get that done, and yeah, go from there. Let's go here, move that. Oh, hello, me. And there. Okay. So, a couple things before getting started. That Udar, hey, how are you? Right, so you'll see that I'm streaming at 6 o'clock p.m. today. I was intending to stream much earlier today, but things happened. I don't know. I don't know. I don't know what to say. I haven't been able to stream at normal times. I've been trying my best to get like a more regular, longer schedule. Has not been happening. Hey, Cropeb, how are you? And that's okay. You know, it happens sometimes. I'm doing my best just to maintain a healthy work-life balance as best I can. And there were just a bunch of things that I had to do for work today, involving like creating a script for the upcoming lecture on, software engineering principles related to Git and version control. It just ended up taking most of the day. Luckily, though, next week is the last week of the course. So after that, I should have plenty of time. Now, like I mentioned yesterday, we are actually planning to take a step back from the Fractal Flame video that's coming up, and instead actually I want to focus on Fourier transforms. However, we've got a bunch of projects that are just kind of sitting in the ether, waiting to be, tackled. So I figured let's go ahead and start tackling those issues. The first like thing that we started, actually there's like 20 things that we started. But the big project that we started but never got anywhere near finishing that I do want to make a video on is Quiltify. Quiltify, which is literally just the process of taking an image and turning it into something you can quilt. Now, here's the thing. We're going to talk more about that. That's the crux of today's video. There's basically 3 steps to this, and we're going to finish step number 2 today, probably, I think, depending on how poorly I coded it before, but I'm like 25% sure we can finish that today, and 25%, that's super high for me. I'm never that positive about anything. The other thing, we have obviously Flameify, the fractal flame generator, I suppose. Both of these guys will take in some sort of image and output a new image that has been modified to some extent. Now, I know kind of what you guys are thinking. Both of these are weird videos for me to make in a way, and I don't really know the best way to explain it other than the fact that these aren't algorithms exactly. Well, they're kind of algorithms. The one relies heavily on color quantization. The other one relies on the fractal flame algorithm, and that's totally fine. But the reason these are weird is that they are applications, and that's something that I wanted to kind of start doing more of in the future. So I think Quiltify is going to be a really just banger video for a number of different reasons, but probably mainly, even if, people might not be so into it here on Twitch, because there's actually a really cool story behind the thing that I'm actually going to quilt in the end. I can't spoil the story for you guys here, but I think it'll get some clicks. I mean, like, also, this particular one isn't about clicks. What I'm going to be like making is kind of sentimental for some reason. So it doesn't really matter so much if the video does well. Flameify, I think, will turn into a pretty good video. But again, it's just some of that software development stuff. So finally, 3. And this is the thing that we really it's been lingering over our head for ages. We really need to tackle it. It's the FFT, the Fast Fourier Transform method in the algorithm archive genuinely needs to be revised. Now, the FFT method is necessary for the fractal flame method anyway, kind of, sort of. In a way, FFTs are useful for understanding convolutions. Convolutions are useful for understanding the fractal flame method. So putting it together, it makes sense for us to do FFTs first. I have an idea of how I want to do some visualization for FFTs that I want to kind of just delve into a little bit. And I think it'll make the Quilituki method phenomenally easier to understand for a lot of people. So that's kind of the hope. And so what I'm actually going to do is for the next few weeks after this weekend, I'm going to focus on the FFT visualization. Quiltify will be basically done with small scale modifications that we'll make later, probably in January. But this one actually can't be out until late January, early February, just because of other reasons that I don't want to explain now. Which means it looks like this one will be out in December, this one will be out in January, this one will be out in February, and then, let's see, there's one other thing I wanted to point out, was that I haven't really decided what I'm going to do for the subsequent videos. But a lot of people have been very interested in like various algorithms that we've covered, but I haven't really turned into videos yet, like DMRG. There's obviously my terminal game that I never finished, but it's called Specterm. There's a lot of things that I kind of want to work on, and I think I'm just going to switch between them. You know, doing some sort of algorithm thing, doing some sort of like terminal video game thing. I'm just going to hop around, see what I find interesting every day. And hopefully we'll get a whole bunch of really good videos coming out regularly. So I just wanted to take, 5 minutes to talk a little bit about the schedule for the next few weeks. And now we can hop into Quiltify, which again, I'm actually way more excited about than I should be. I know, like, yeah, coding a quilt, maybe it's not that cool, but like, I think it's cool and I'm pretty excited for it. I've been wanting to learn to sew for a long time. And I know quilts are probably not the best thing to learn to sew with, but, when you think about it, what is a good thing to learn to sew with, right? Like, you can sew shirts and stuff, but when you think about it, shirts are kind of, I don't know, I find them a bit difficult to get, the right size and shape and everything. Well, maybe a shirt's not so bad, but like, for example, pants I would say, be pretty difficult. So I'm like, what's an easy thing to sew that will take a lot of time potentially, but will give me a lot of experience? Well, that would be a quilt. So what is Quiltify? Again, the idea is that we take an image and we return back something that could be quilted. So this means we take the image and we do a couple of different steps. The first step is color quantization, which is basically just the act of taking all the colors in the image and returning back a subset of the colors that will still pretty much return back the same image. So over here, you'll see we have a video that we made last time of an image that looks something like this. The first variation of color quantization, which I think is 32 colors saved, and then 8 colors saved. And that's kind of the idea. You have, you are taking the image and you're making it way more, just, I don't know, abstract in a way. So that's the idea of color quantization. After that, we have another bit, which I called quixelate, which is basically turning any of the color quantized pixels into something that I'm calling a quixel, which is a quarter square, something that you could then like quilt up. And then finally, after that, we need to apply some sort of texture. I don't remember what I called it. Texture. It basically just means if you have a blue color, replace it instead with a blue texture. This won't be too bad. And in fact, I'm not planning to do this step today. It's kind of an optional step. I'm hoping to get this step done today, but we'll see how far we can get. Again, guys, if you have any comments, questions, concerns, ideas, feel free to let me know, and I'll totally address it as soon as I see it in chat. Outside of that, I think we can just go ahead and hop into it and see what we did last time, because quite frankly, it's been maybe a month since the last time I looked at this, so I don't really even remember what we did. So using Julia _project, using revise, and then we're going to do using Quiltify and see what we got. What's a quixel exactly? That is a good question. So you have some sort of image, which will be, we're just going to draw it like this. 1 second. Let me get some lines in here. So here's your image. I'm just going to make it like a 5x5 square or something like that, just because I don't want to draw so many lines. Yep, something like that. So when you code something, or when you're going to make a quilt or something like that, you're going to have to basically turn this into some sort of fabric that you can sew in. So this means that a quixel is one of 3 things. It could be a square. It could be a square, a half square, or a quarter square. And this basically just means you're taking your image, again, presumably the image has way more pixels than, 5 by 5, and you're splitting it up. So like, for example, you could just say this entire square is now a pixel. So what you're going to do is you're just going to sum all the colors, and you're just going to find whatever color is closest to and say that's the color of all these squares. Or you could split it in half, and you could say, for example, this side is green and this side is blue. Or you could cut it up into quarter squares from there. And you could do this. Let me make that pink as well. Or you cut it into quarter squares, so each square has its own color or something like that. It's literally just a way to quantize your pixels. It's just a way to batch them all together such that you can output something essentially that you can print. So these all four could be different colors, for example. And yeah, that's kind of the idea. We have the concept of pixels in an image, but in the end, what we want is the ability to turn this into some sort of fabric that we can print. So we're going to say that n pixels, your quixel size is going to be n pixels wide. It's going to be either a square, half square, or quarter square, which is going to define how you divide it up. So that's how I'm doing it right now. There could be a more intuitive way to do it, but this is kind of what I'm thinking of right now. And I got asked this question a lot last time. Some people were asking what a quilt is, so let me just Google quilt, just to make sure everyone's on the same page. Images. So you want to bound the amount of pixels? Essentially, yeah. So like, let's see. So here, here is a quilt, for example. Here's another quilt with half squares. Well, triangles, not really half squares, but here's one with the quarter square pattern that I was showing before. So see how all of the, like, view image. So here you can see that all of them are like some sort of squares or set of quarter squares or half squares or something like that. So that was kind of the idea. I just wanted to turn it into something that I could then just cut and I could apply. Yeah, it is kind of a weird, like, it's a weird thing. Like, it's definitely a weird thing. But I'm actually pretty excited for this. Like, I'm almost as excited for this. In fact, in some ways, I'm more excited for this than I am the Fractal Flame Flamify package, which is still pretty cool. And also Spectrum, I'm getting really into Spectrum again. I've been like outlining like a bunch of different levels that we could do for Spectrum and all of these different things that people could be doing, all this cool stuff, like, voice acting for a terminal game. I thought was pretty cool. Like, I want like a cool sounds. I don't know. I'm actually really excited to do, like, basically I want the terminal game to have like really cool like music in the background, and like I was thinking about how to do that. There's a whole bunch of things that I was expecting that I want to do with that game. But I just wanted it to be a terminal game, like through and through terminal game, just with good music and everything else here. I'm working through crafting interpreters, currently making scanner tokenizer. I'm literally describing my work. Bachulaos wasn't talking to you. I'm pretty sure he was talking to me because I was not talking about Quiltify. I was talking about some other project. LS source. Okay, so what do we have here? Why did I just LS source and then I don't know what I was doing there. Let me just cat all the files in source. I don't remember what I was doing. It's okay. We'll figure it out. What files have stuff in them? That was dumb. I don't know why I did. That was just stupid. That didn't give me any information. Let's go to clear. Clear again. And now let's just do VI source. And I'm going to go into Quiltify first to see what we did. So it's basically quantize, quickslate, and fabricize. Wow, that was a... I don't know why I didn't call it fabricate. Because fabricate would have been a nice pun, but that's okay. So now we're going to go into VI source, and I think we have quantize already done. So we have quantize.jl. This takes a mutable struct color box. Why? What? So what is a color box? It's color, which is a union of RGB and nothing. It is a set of children. Oh, okay. The color box. Right. Okay. So to do color quantization, you have some sort of three-dimensional RGB space. R is your X dimension, G is your Y dimension, B is your Z dimension, or something like that. And so what you're doing is you're creating a color box, which is a subset of essentially all of the colors in your image, right? And then inside of that, you then split this up into 8 octants, right? And each octant is going to be a little bit red, a little bit green, a little bit blue, whatever. And the idea is that these then have children, and basically you recursively divide up all of these boxes until each box only has one child in it. And the idea is for color quantization, you basically just want to pick out the top 8 or the top, 32, the top whatever. It's the top power of 2 colors that you want to keep. And that's kind of the idea here. Now, I don't think we have a chapter on color quantization. We do not. So we're going to have to, clean this up a bit. And also, we have this concept of a color set. So let's see, we have the color set is going to be a set of colors. We have quantize in here. So what I think I want quantize to do, I think I want quantize to also output a color set. Because like I said before, when we have our set of quixels, again, a dumb name, but it is what it is, we want to basically make it so each quixel is going to be one defined color in your color set. Oh, maybe we don't need that. Maybe we could... Okay, wait, no. We can just find the median color. No, can we? That's a good question. Okay, hear me out. So here we have these 4 constituent quixels, right? So we know that each of these colors is a color quantized object. So we're just going to say this pixel is blue, this pixel's blue, this pixel's blue. We'll say that all of these pixels are blue. And then we'll say all of a sudden these pixels turn orange, right? Okay, so what we could do is we could choose the median color for this particular quixel, which would mean we'd color the entire thing blue and just ignore these orange colors. But in actuality, what we might want to do is average all of the colors and then say that we're looking for the closest color in the color set. Because what if one of our colors in the color set is green, we'll say, and when you mix blue and orange, you get something kind of green-like. I think. I don't really know my colors, but let's pretend I do. And that would make this whole thing maybe green instead of blue. Does that make sense? So, which might be a better representation of the colors available. I have a feeling, though, we should probably just do the median. Because, like, for example, let's say all of these pixels up here are also blue. Let's just say it's like a blue sky. Something like this. Average and then quantize. We could do average and then quantize as well. Yeah. The problem with that is but getting green around the sun is weird. I agree. That's why I think we should just take the median value. So the reason I wanted to, and again, I'm not really sure. You might be right that it is best to average or to turn it into the set of pixels or quixels and then quantize. I think that might be best. But I was trying to think about it, and I was thinking that, how do I put this? I was thinking that, in the end, I'm going to want to sew something, right? I'm going to want to, I actually have bought a sewing kit, and I want to sew something. So because of that, I was thinking it makes more sense to first get the constituent set of colors and then to create an abstracted version of that in the quote. So, how does median work in multidimensional spaces? I don't think we need to worry so much about how this has to, I don't think we have to worry about it in multidimensional spaces. All right, Seth, how are you? I hope you're having a great day. Okay, so I think, okay, let's just look at the 2 of these. Okay, so I'm going to go back here, and I'm going to just color this in. So we have blue up here, blue, blue, blue. I'm just going to make it blue and orange. So we have blue up here and orange down here. Okay, and let's say our color set is blue, orange, and what is blue plus orange? Median is the value that minimizes norm 1 distance. Oh, that's probably what we want then, actually. So the way I would quantize this would make it so would be, ooh, this is actually kind of complicated. Blue and orange are opposite colors. Are they? Blue plus orange is gray. I think the median is the median of each coordinate. Okay, so if blue plus orange is gray, then we're going to do gray. All right, so these are our 3 colors. Okay, Good. So we'll say it's gray because that's the closest color I have up here. The median of I think the median is the median of each coordinate. Okay, so one way we could quantize this is by doing this, color all of this area blue. 1 second. Unfortunately, Zernal doesn't have like a bucket fill application here. So we color all of that blue and this orange, which I think is fine. The other way that this would be quantized would be to color all of this blue, all of this orange, and then to color the median here gray. And I think this is why we want the median, not the average. Because this would just potentially have like weird colors. Great nut, but thank you. This is not fractal. This is not fractal stuff. This is Quiltify. So we're basically coding up a quilt. It's different than the fractal flame stuff that we were doing before. It's just a separate project. I wanted to get this done. Like I said, we're going to be taking a step off from doing fractal flame stuff. You need to give the correct weight to each cell. Okay, so which means that you can give colors. I think median is the median of each coordinate, which means it can give colors not in the in-out. I don't fully understand what you mean by that statement, which means it can give colors not in the in-out. So when I was saying take the median color input, input, this is fine. Input in is, I think we meant the same. So median is different than mean, right? If we took the mean, then we could get colors that are not in the input, and then we'd have to sync it to like gray, for example. Like blue plus orange is not going to be gray, but its closest cousin is going to be gray. So then we sync to gray because gray was the quantized color that we had before. I think if we're going to turn it into the Quixel set and then quantify or quantize, it makes sense to do the mean, like it makes sense to do the average. But if we're going to quantize first and then do the Quixel set, then it makes sense to find the median. And I think you guys have convinced me. The correct way to do this is to find the set of Quixels first, and then find the no, wait. I'm confused here. Okay, let's say we have a strong border. Okay, I'm sorry. I need to think about this. So, let's say we have a strong border where we have a yellow sun. Here's our yellow sun, and then surrounded by a blue. Let's just do it this way. So we're gonna do bucket fill. Where's our bucket fill? Here it is. So we're gonna do a blue sky, and inside the blue sky we're gonna have a yellow sun. What I'm hoping to do is maintain the fact that we have sharp borders here, right? So this has to be a sharp border. So if we average first, then we could get kind of a blurry border. Yeah, so I want the median. Let's do the median. Median of red, green, and blue would be black. No, the median here, by median, basically I'm saying that if most of the pixels are blue, we're just picking blue. That's what I'm doing. I think the mode might be correct here. I think the mean and median would produce different looks on the output. Mean would be better for realistic pictures, and median would make the better looking things that look like a quilt pattern. That's what I think as well. That's called the mode. Is it? Oh, you might be right. Sorry about that. So it said take the middle. Okay, my bad. I was saying, so ignore me for the past 20 minutes. When I said median, you're right. I meant mode. Median, I meant mode. Sorry about that. You're totally right. Sorry about that. Mode minimizes the norm, zero distance. The mode is when you take the most common element. Yeah, that's what I wanted. I'm so sorry. You guys are completely right. I'm just dumb. I forgot like 3rd grade math. Just ignore me. Just leave the stream now. In fact, don't do that. But you know, hey Jonsen, how are you? So Delphi, I just realized I was dumb. I'm sorry. Is a reflection of the sun in a puddle? What do I win? Nothing. Let's see. You could make this a configurable option. I think we can. So for now, I think we'll do the mode. Don't get yourself down. This is at least 4th grade level stuff. Okay, fine. Yeah, you're right. You know, as Dr. James Schloss, I can I can do 4th grade level stuff. Okay, let's get back over here. I think the first thing I'm gonna do is the mode. And you're right, Crophead, we should make it configurable. But let's just implement the mode today, get something, and then we're gonna worry about like, you know, doing other stuff later. Because I think implementing the mode is a good thing that we can do in the next hour and 30 minutes. So I think let's just go ahead and tackle that. So we're gonna go into VI source and Quixelate. Okay. I have a function Quixelate, so the first thing I need to do here is create some sort of struct. Should I make it mutable? I believe I should. So I wrote this down the other day as I was kind of thinking about it. So the Quixel again has 3 different modes. It has full, half, and quarter. So what I might do is I might actually have an @enum at the start of this. That's full, half, and quarter. Now here's the thing. I need to make sure that I remember how enums work. I think it's A, B, C, no comma. I think that's it. So A is... wait a second. So B is 0. Wait a minute. What is A dot B? I've completely forgotten how enums work in Julia. I've used them multiple times. Okay. So we're gonna do @enum, and I think it'll be... So B over here is gonna be... B is of type A, so I think it's the type first. So this will be Quixel. And then down here we're gonna have struct. And I think it does have to be mutable. Quixel. Okay, and here we're gonna say... Okay. Quixel type. So here we're gonna say type is gonna be of type Quixel type. If this compiles, I'm gonna be really surprised. Then we also have a color, which is going to be of type union. And I just want RGB and nothing, just in case. And then we're also gonna need the size, which is going to be, we'll say length, which is gonna be int64. So this is gonna be pixel length, the number of pixels that each Quixel is going to take over in a way. So like if it's a 5x5 grid, the Quixel length will be 5, is the idea. Hey Jumpout, how are you? Okay. So now we have Quixelate, and of course we're gonna have a I want to call it a mode, but then I just realized the mode that I would read in is called mode. So that gets kind of complicated, but mode quantization format maybe, average method. Sure, we'll call it average method. Good. Will this compile? No idea. So let's see what we got here. Let's go into VI source, Quixelate, and let's just try running this. Sorry, quantize, go down here. So we have quantize of some sort of image. So let's do using images, and let's just read in an image and just see what we can do. Right. So, okay, fair enough. Failed revise, error type union, expected type got value type nothing. Fair enough, that's my bad. This should be capital N. Try that again. I'm assuming this means it compiled, which should be fine. So, this whole thing is kind of messy, but that's okay. It's fine. It's fine. Whatever. I'm not gonna worry about it too much for now. Okay. So, let's think about how I actually want to do this. So, what I'm going to do is I'm going to read in some sort of image, and I'm going to go through all of the pixels in the image and basically batch them into sets of 4. So let's go ahead and start with the case that all of the pixels are square pixels, right? We don't have the half square, we don't have the quarter square, it's just all square pixels. So we don't have to worry about it too much. And yeah, we'll just see what we can do. Okay. Fun fact, I have to set up a make.bat file containing the GCC commands I need to compile this project so I can pretend I have a make file on Windows. Wait, what? You don't have make files on Windows? How do you make things on Windows? Chachu, thank you so much for following. Really appreciate it. Chachu13. Okay, so again, we're just going to assume they're all half squares, and we're just going to implement something that might or might not work. We have no idea. We're just going to try it. So, how exactly are we going to do this? So we have some sort of image. So journal, new page before. We have some sort of image that is some sort of size. There's our image. And I want to split this up into little squares. So square here, square here. Pretend I can draw squares. I can't. Spoiler alert. There. Perfect. All right. There's all the squares. So we're going to go through all of the IJs, probably actually in multiples of... Okay, I know what we're going to do. So in here, we're going to say for I is equal to 1 to quixel size. I use WSL if I need to use C. Yeah, see, I know a lot of people that do that as well. I kind of... Yeah, anyway, so we'll do quixel size to size of image of 1. And here, and we're going to do for J. Quixel size to size of image of 2. Okay, now obviously this is going to run into a bit of an issue if if the output image size is like if the image size is not a multiple of your quixel size. So what I think I'm going to do in here is I'm going to basically create an output image, which will be, oh, what will it be? So if we do, we have to figure out how many pixels to like cut off or add to it. So let's say the output image is going to be equal to RGB of 0 for I equals 1 to size of I want to do okay, I think it's gonna be size of image of 1, and that would make it the same size. So then we want to subtract out size of image of 1 mod quixel size. And then we should do quixel size minus that. I think, is that right? Okay, so let me think about this. I missed this one. This is a really cool image. Hi, hey Andrew, how are you? I know you see normally there are versions of Make for Windows. Yeah, I know CMake works for Windows, but I haven't really used it that much. I just know it exists. Okay. So what did I just do? Let's just see if this actually works as I thought it would. So I'm going to create an array which is going to be of size zeros of 10, 10 or something like that. Okay, we're going to create a new array called R. That's going to be of size 10, 10, and we're going to say we have a quixel size of, and we're just going to call it Q size equals 3 or something. Okay, so now if I do size of R1 modulo Q size, I think the answer will be 2. No, 1. It's 1. Yeah, it's 1 left over. So then if I do Q size minus that, I think what I want to do, I think it's Q size minus that, because that will mean that we are going to cut off 2. No, we want to cut off 1. Wait a minute. Is it always just going to be cutting off? I think I did this wrong. I think it's just going to be this that we want to cut off. So I think what I want to do then to create an array of the appropriate size, I think what I want to do, it needs to be a multiple of Q size. So I think we're just going to say B is going to be bar is going to be equal to 0 for I equals 1 to and then I think it's going to be size of R of 1 minus that for J is equal to, and then we're just going to do the same thing for size of R2. And just put 2's in here, and another 2 in there, and then do this, and see what that does? Missing comma, of course. I think I'm missing a parentheses here. Okay, that created an 81 element array. I was expecting, first of all, good, it's 9 by 9, great. I was expecting it to be a 9 by 9 array, not an 81 element array. What do we have here? Are you doing this for geomapping? No, I'm literally coding a quilt. I'm coding up something that I could then sew into a quilt. That's all I'm doing. Like, I know it sounds, maybe, I mean, I know I'm making this more complicated than it needs to be. Like, no doubt. But that's kind of the point, you know? Also, what is geomapping? I'm cool. Thanks, I'm cool. CMake's not equal to make. You are correct. However, every single time I've used CMake, I've basically only used it in order to generate a make file. It's always CMake dot, for example, make. Okay, so I want to then say this is going to be, put this in an array, geographical maps, do that, and this is going to give us a 9 element array of arrays, which is also not what I want. So how about I do this differently. Instead of doing it this way, let's say that, hear me out here, y dimension, we're just going to do, the output is going to be equal to, array of RGB, undefined, and then we're going to do size of image of 1 minus size of image of 1 modulo pixel size, and then move the next one down to the next line, which will just be basically the same thing for 2, and I think that'll work. Yeah, R2. Great. So let's just make sure that actually does what I expect it to. So we're just going to grab this line and none of that's defined. So let's just R, Q size, R, R, and Q size. Principle, this should create a 9 by 9 array. It does. Okay, great. So let's mess with this a little bit. Let's say A is now going to be equal to, we'll just say 1920 by 1080. So R is going to be equal to zeros of 1920 by 1080. And then we're just going to say our pixel size is going to be equal to 7. I don't know, something dumb like that. And now we're going to say the out is equal to that. This creates a 1918 by 1078 array. Is 1918 divisible by 7? The answer is yes. Is 1078 divisible by 7? The answer is also yes. Great. Okay, so all we did right now is we took our array, which is a size 1920 by 1080, and we turned it into a new array that was slightly smaller than the other array. So now what I want to do is, okay, I need to think about this again because I'm actually not sure what I want to do now. So now these for loops should work, but they're going to cut off a little bit to the left or a little bit to the right. But let me check how for loops work in Julia. So for I is equal to 1 to 10. Do we output 10? That's my question. Print line I, and we do print out 10. So that means that it will go, let's go in leaps of 3. And it goes, it does stop at 10, but does that actually make sense? 1, 4, 7. Let's go in leaps of 4. Okay, so 1, 5, 9. So it does not output 10. Perfect. Or it doesn't output the next after 10, which is what you would expect, but I wanted to make sure. Okay. So in this case, what I want to say is, start X, or start Y actually, is going to be equal to size of image. Yeah, it should be size of image. So here we're going to do floor of int. Okay, let's try that one again. Floor of int, size of image of 1, modulo pixel size. And we're going to do start X, which is going to be this. And then we're just going to do start X and start Y here. Oh, and start X. Oh. Okay, so now what we've done is we've taken our image, again, 1920 by 1080, and we've made a new output array that is divisible by our pixel size. So we're just going to bin the data, and we're just going to go through. And then what I did is I slightly centered it. I offset it by just a little bit so that all of the bins, like, we're not going to take off more from the left edge than the right edge. We're going to try our best to take an equal amount from both sides. That's what we just did. So now we need to start going about binning the data. What I need to do here is I need to sum all of the colors in our RGB array and just output. Oh, I don't want to sum it. I want to find the mode. Mode. Does that exist? Using linear algebra. Mode. Does that exist? It does not. Okay, so we might need to make our own mode function. Right. Cool, fair enough. So let's go ahead and create our own mode function. I might call it Quixel mode or something, just because I don't want to confuse it with it. Although we could just call it mode, that just acts on an array of RGB values. Maybe. A compiling interpreter calls this sort of thing hand rolling, and I think that's cute. Yeah, I guess. What type of thing, actually? You're going to hand roll a mode function? Oh, yeah, fair enough. Okay, so let's actually do this as mode, and we're going to say this takes in an array of RGB. I did that entirely wrong. What am I doing? Mode, it takes in image. Sure, it just takes an image. And here, that should be fine. But I do want to specify this on array of RGB. Let's do RGB n, where n. Sure, and we're gonna say n is specifically within int. Sure, that'll be fine. So, all we're gonna do is we're just gonna go through all the elements, and we're just gonna count how many times a particular element is a particular value. Yep, I like it this way. That way, our average method, we can just call average method on this, I think. So we'll see how this goes. This will be interesting. I'm not sure how to write this properly in Julia. So I'm not sure how to write this properly in any language. So we're just going to kind of knock it out. So what do we want to do then? We're going to have a set of different values available in our image. There has to be an inbuilt mode function. Let me just make sure I'm not doing something dumb. Mode function. Mode function Julia. Function to calculate the mode in Julia. Let me just make sure. I feel like I'm using statistics. Okay. Using statistics. Now let's try mode. Does it exist? It does not. Okay. Undefined mode not defined. Stats base dot mode. This is from a while ago, not too long ago. Let's just see what happens. Let's just add stats base. You can use that and take the argmax. Oh yeah, I could do that. Yeah, actually. I would assume that'd be in statistics. Okay, let me just do add stats base. Because it said there was a mode in that package, so we'll see. Might work. Who knows? We'll just give it a second to you know, build everything and do its thing. It's updating stuff, so okay. Using stats base. See what we got. Oh no. Oh jeez. Precompiling stats base worked. Mode exists. R is going to be equal to 1, 2, 3. Okay, try that again. 2, 3, 4, 4. Mode of R 4. Perfect. Exactly what you want. So let's see if it works for RGBs. RGB of 1, 1, 1. RGB of 0. RGB of 0. Using images. I feel like there was a package conflict or something going on. It doesn't matter. Nothing matters anymore. Let's just... Hey, Fulster, how are you? I hope you're having a great day. Okay. We're getting there. I think we can get the mode version of this particular Quixelate function done by the end of the day. I've got another hour in stream. That's plenty of time. We're just going to give this guy a second to load images. And then we'll just go from there. I will say that precompile time just sucks in Julia. It's really bad. But, you know, it's fine. Pretty good. Fixed a door frame and found some lost keys. Oh, actually, earlier today. Okay, I didn't fix a door frame, but I will say I used some WD-40 on the hinges of one to make it less squeaky. Now, I know what you guys are thinking. You shouldn't use WD-40. You should use actual oil or grease. I get that. I totally get that. But we didn't have grease. The door is really squeaky. I just figured using WD-40 for just a bit would be okay. I don't know. Maybe I'm the bad guy. Okay. So here we're going to do R is equal to RGB111. And let's just do mode of R. Perfect. Okay. So now if we go up here and we do using stat space, I think it's capital there, it will make it worse in the long run. Yeah, that's probably true. But actually, I don't fully understand why, right? Like it just allows the metal corrodes more. Is that what happens? Or like, I guess that has to be it, right? Because I assume that WD-40 is water-based solution or something like that, whereas the grease is like an oil-based solution, so it lasts longer or something. I don't really know. I actually have never really... I mean, how do you grease a hinge? Do you have to like take it apart and you... Anyway, I'm rambling now. I don't know. Sorry. So using stat space should be okay. So now what we should be able to do is read in a view of the image. So let's go ahead and read that view in. So we're going to say color is going to be equal to mode of the array subset that we're reading in. And just to be sure we can actually do this right, let's say R is going to be equal to RGB of 0. Well, let me just make sure mode works. So R is going to be equal to zeros of 10 by 10, and mode of R should still work just fine. Perfect. So now we just have to read in the appropriate subset. We have the I and the J that we're starting at, and we should be able to... We should be able to go up to... Let me think. I think WD-40 is a solvent for grease. Oh, okay. Fair enough. I'm sorry. I should know better. Eloquent, thank you so much for following. Really appreciate it. Okay. So we have the mode, and now we just have to read in the appropriate array. So we're just going to say this is going to be image, and we need the subset of the image that we're going to read in. I completed the chapter. Now I have, hopefully, a complete scanner tokenizer. Oh, super cool. Yeah, great job. Okay. So what is the subset here? It's going to be, can I just do I to Quixel? I plus Quixel size? And then J to J plus Quixel size. I feel like this is going to go over a little bit because you do iterate on the last. So what we want to do here is we actually want to have the start X to start. Let's do it the other way around. Let's do it I minus Quixel size. 2I. And J minus Quixel size. 2J. And then up here, we're going to say start Y plus Quixel size. And then start X plus Quixel size. So we're just going to start slightly offset, and then we're going to look back a bit. I'm just doing it this way. We're either going to have to subtract from the end or add to the start. I just decided to add to the start instead. So here we're going to say the color is going to be the mode of all these values, and that should give us something that we can work with. So now what I'm trying to do is return an array of quixels, and I just realized just now that the whole idea of a quixel at this point in time is relatively useless, because I'm just going to return back. I'm just going to return back the image. So now we're just going to say output out of slightly more complicated, but I think it's the same thing. I minus start Y. I minus start Y. Minus Quixel size. Right, so we just have to offset it a bit because our output was not offset. 2. I minus start Y. And now we just have to do the same thing for J, except with start X. Does that fit on the same line? I think it does. But actually, in fact, I think I want to move this down to the next line. Oh, this is a messy call, but it is what it is. J minus start X. J start X. J. And then we're going to say dot equals to color. Okay, and then at the end here, we're just going to return out. See what happens. We are going to read in an image, quantize the image, quickslate the image. See if this works. So we have images already. So let's say image is equal to load. What do we have here? Well, let's do the pride flag again. Why not? Let's go. Pride flag. Give it a second to precompile image magic, and then we'll quantize that. And then we should have a quantized pride flag. So let's do load. I'm sorry. Using image view. Give it a second to precompile image view. It's okay. We'll get there. And then I think this function is all we need for square quixels. Now, obviously, we also want half squares and quarter squares, which we have to deal with as well, but we'll just deal with this one step at a time. Cool. I think this is turning out pretty well. I'm actually a big fan of this. Let me get some water. Okay, and now the next thing I need to do is go into, well, let's do IM show first of IMG. And I think it'll be like an upside down pride flag or something like that. Oh, it's right side up. Perfect. Okay. So now in here, what I want to do is, what am I doing with my life? Give me a second. I am going to vi source quantize, and figuring out what the call is for that. Move down here. So it's just quantize image and color number. So I think I can just do image 2 is going to be equal to quantize of image, and color number we're just going to set to be 8, and see what that does. Probably because it's Quiltify dot quantize, using Quiltify. Okay, now it's gonna break. Everything's gonna break right now. I'm like 50% sure. And that's okay. Oh, it didn't break. Sweet. Okay. 2.1 RGB. We are outputting stuff. So now let's do IM show of img2. Quantized pride flag. Let's go. Okay, so now we should be able to run the next thing, which should be just quixelate of the image with the quixel size. See what happens. So here we're going to do image 3 is going to be quiltify.quixelate of the image, and let's keep the image size 8. What? Dang it. With L type at index 0 to 8, 0 to 8. Okay. Right, okay, we'll figure it out. This is going to be on line 25, which is going to be on the output. Okay, that's fair enough. Start Y must be 1. Oh, I just realized something. Start X and start Y, the way that I've done this could be 0. Which doesn't make any sense because Julia starts counting at 1. So that would mean that this needs to be, start Y is going to be this plus 1. Try that. Okay, still 0 to 8. That doesn't help in any way. Let's output start X and start Y. See what it is. Wait a minute, what? Oh, I forgot to use revise. Crap. Gonna have to redo all of that. That's okay. Give us a second. Okay, so now we have to do using images and image view, which will take some time. So if you guys have any questions or anything, feel free to you know, have it in chat. Okay. Let me just very quickly say, Aqua 188, that yeah, don't use that language in chat. It's super offensive. So, you know, like, just sorry about that. Cool. Okay, let's just keep going. Print F typo could be. Let's do image is equal to that. Sorry. img is equal to load pride. Take a look at that. Sorry, I wasn't looking at the mod chat for a bit. So let's do im show of image. Get ourselves that beautiful pride flag. And then take a look from there. Okay, great. So now we're going to quantify that again. I do think I see an orient. Yep, you guys are right. Sorry about that. Thanks. Okay, so now we're going to do img2 is equal to that, using Quiltify. Okay, give that a second to precompile. And yeah, we'll just see what happens. Sorry, jump out. Guys, I didn't understand what you were saying initially. I didn't see it. Okay, so now let's do img2 is equal to that. Give it a second to just do its stuff. And then we are going to try img3 is equal to that. Attempt to access. Right, okay. This is outputting start X and start Y. I needed a tab in there, which I didn't have before. And this should do, yeah, does the same thing. So I think what I want to do is have the +1 be, ooh, this is annoying, isn't it? Let's just do 1+ here. Oh, Why my bad? 1 plus there and 1 plus there. Write that. Go over here. Try that. Okay. We have undefined values. Let's just do IAMShow of IMG3. IAMShow. See what it looks like. Beautiful. Let's see. East Onco 7. Thank you so much for following. Really appreciate it. Let's do image 2 just to make sure we were reading something in. Yeah, okay, so we were reading in the appropriate flag, but it did not output what we were expecting. So the question is, why not? That's a very good question. Why do we still have undefined values in our image? Also a very good question. Yes. So a lot of them are defined, but for some reason these guys are not defined, which means that we are not counting right. That's what it means. So we got to think about how we can count correctly. Let me get a quick sip of water. And then I think we can just try to figure it out. So what we're doing here is we are saying that our start X and our start Y is 1 and 7. That doesn't make much sense, actually. So let me output the size of out here. So we're also going to print line, so start X, start Y, and we're also going to print line size of output, new tab, size of the image, new tab. And now we're just going to try to do IM3 again. So it's going to be 408, 624. Both of those sound like they're divisible by 8. But let me just make sure. 408 divided by 8. 624, yeah, is divisible by 8 as well, I think. Yeah. Okay. You can call me Easton. Happy to be here. Doing some other work right now, so I'm going to be lurking here this evening. Yeah, thanks for coming in. I totally know what it's like. I lurk in most streams as well, so don't feel obligated to chat if you don't want to. I appreciate all the chat, also appreciate all the lurks. You know, it is what it is. Okay, so we got to think about this. So what I did is I basically said the following. So we have some sort of image, right? And we have to parse this image into a bunch of squares. So what I said is that our output array is some subset of our input array. So it's going to be slightly smaller. And I gave it some sort of offset in X and Y, such that I just realized I have to divide these by 2. It's kind of centered a bit. So let's try this again. Image 3. Attempt to access 408 by 624 array with L-type RGB at index 1 to 9, and then 617 to 625. 617 to 625. Okay, good. So, do you read in image 2? Image or image 2? We read in image. Well, it doesn't. We should be reading in image 2, correct? But also, that doesn't fix our indexing errors, because right now we're having severe indexing errors. Oh, but maybe it does. Yeah, okay, well, we can think about that. Because maybe they're staying undefined because the color doesn't have any mode that it's output. No, that doesn't make any sense. Yeah, that doesn't make any sense at all. Okay. So, we're saying 1 to start X. So it's going to be I. So, in the case that our start X and our start Y are maybe, okay, so I is going to be, I will start counting from 1, and then we're going to give it an offset depending on, you know, how much we have to offset it by. So we offset it by like maybe 4 pixels or something like that. And then we say we also offset it by pixel size, and then we just go in steps of pixel until we've hit the edge of the image. Our colors all seem to be fine. We are getting colors out. The problem is coming down to, hey, Brokolikoff, how are you? I hope you're having a great day. So we have I start. what is a quilt? That's a quilt. We're basically taking something that will take any image and output something that looks something like this. That's what we're doing. So, Elwoods 300, thank you so much for following. Really appreciate it. Okay. Which I know sounds kind of weird, but you know, I think it's kind of cool. So I'm pretty excited for the output here. We're at the step right now. So we've already done color quantization, which is what you're seeing in the upper corner, where we take an image of n colors and we cut it down to an image of less than n colors. And then we, now we're at the stage where we're quantizing it into little squares so we can then sew it up. Literally a quilt, not some fancy data structure. Yeah, it's literally a quilt. I think a lot of people, like, for some reason, I don't know, maybe they think too highly of me or too highly of programmers on Twitch, but when they're coming here and they see that I'm coding a quilt, they're like, what's a quilt? And I'm like, it's exactly what you think it is, right? Literally quilt. I wish there was a fancy data structure called a quilt. Maybe I'll invent one. Elwoods 300, thank you so much for following. I think I just said that. I apologize for that. I don't know why I thought it was a new follow. Okay. But yeah, I think a lot of people think maybe too highly of what I do on stream because they're like, oh, this quilt thing sounds really cool. It must be like a really cool algorithm or data structure. It's like, no, I'm doing something normal for once. You know, something that isn't as like ridiculous. It's not like an FFT method. If you want FFT methods, come back Monday. We'll be doing FFT methods then. But right now, just, you know, doing something casual in a way, just kind of chilling, hanging out, doing stuff. Okay. So, right, what am I doing with my life? I minus start y is going to give you 1. So quixel size is going to be 8. Should these be... Okay, I see the problem here. If quixel size is 8, then it's going to grab 1 through 9 in this case. So we actually have to do a minus 1 in here as well, I think. I minus start y minus 1 and another minus 1 in here maybe. Let's see what that does. Did something. So let's do I am show image 3. Please just show something. Look at that blocky pride flag. All right. I'm actually kind of excited about that. Look at that. Look at that. It's like, look, okay. I know. I know. Okay. Like the, it's not great. It looks like I did some stupid pixel, like coloring of, so this was the original image. I basically made the image worse. Like this was the original image, right? And then here's the image we turned that into, which is distinctively worse, but has its own defined feel. And then we turned it into this monstrosity here that you see before you. I quite like that. All right, what do we have here? Let me catch up on chat. Quantum interface for light transmission. That holds promise, actually. Let's go. A programmer friend of mine told me that she actually used to quilt and sew, and she feels a lot like concepts she learned through those processes mentally prepared her for programming and computer science. Also, the render looks pretty great. Thanks, man. I'm actually really excited for this one. Like, it looks way better than I thought it would. Like, okay, admittedly, I still would have to go in by hand, and it doesn't do contours very well. But what I think it would do very well, hear me out. I just deleted chat. Why do I keep doing that? Let me just not delete chat anymore. It's okay. I still have my side chat up. I still saw everything that you saw. Give us thanks for the pride paint. Okay, so let's go ahead and clear here. Sorry about that. Deleted chat. Make chat read only. LGB flags from 2D indie game on Steam. That's kind of what it looks like. But also, I think it will work very well with continuous functions. So this is what I want to try next. I'm actually going to just hear me out here. I know this is a bit weird. CD into project Simuleos. L is here. CD into domain coloring. Oh boy. Let's go into Mirage Poly2 .png. And I'm going to take, like, look at that's already a quilt. I mean, look at that. I'm going to take one of these guys and see what we can do. Maybe, I mean, if these just didn't have the contour lines on them, I think they'd be perfect. So maybe I just take this one for now, and we just see what this looks like. So let's go ahead and move that over. So which one was that one? That one was just out.png. Wonderful naming schemes. So CD projects, Quiltify, L is here. And now we're going to CP, project simuleos, domain coloring, out.png to just domain.png. Okay, so let's go over here, say image is going to be equal to domain, load of domain.png. See what this does? Oh, PNG files. Oh boy, bisexual pride. Yeah, cool. LGBT flag from some 2D indie game. Okay, so let's see what happens if we do IM show of image. Perfect. Let's do img2 is going to be equal to quiltify.quantize. This will take a little bit of time, if I remember correctly, because my Quiltify function is slow. So specifically, the generation of the octree tree for RGB space is slow. Wish it was faster. It's not. We could probably speed it up with some sort of parallelization, I guess. And the algorithm's probably slow for various reasons, but we'll just let it go. No issue. Oh, this would actually be super easy to parallelize when you think about it. Yeah, we could just grab batches of the image. Okay, so if I do im show of img2, what do we have? Kind of weird looking. Different than I was anticipating, but not bad. So now let's do img3. Oh, crap. We have undefined. No. Oh, I was so hopeful, but now, so, okay. We're counting wrong. Ah, so hopeful. We were so close. But yeah, I think this looks really cool. Oh man, this is amazing. Okay, let's keep going. So we're gonna go into VI source. What am I doing with my life? Quixelate.jl. Again, just get square pixels. The square pixels are giving us undefined, which is not great. So let me... I'm going to cast all of these guys to zeros for now. So we're going to say for I is equal to 1 to length of output. And here, we're then just going to say out of I is going to be equal to RGB of 0. This is just making it so I can see what's going wrong a bit more. And just give it a second. So this, at the very least, should give us something that we can look at. Okay. That does not look bad. I'm actually surprised at how good this looks. I'm actually blown away by this. Like, we found a way to just pixelize anything. Like, and of course, like, maybe that's not hard, right? Like, maybe it's something easy that everyone already knew. But I think this is quite nice. Like, this genuinely looks like pixel graphics. And I'm actually really stoked about that. What language is this? It is Julia. So yeah, okay, so we still have some issue with counting that we have to figure out, so let's figure that issue out. And then I think when we add the half, could you imagine this with the half pixel? Like, this is going to be amazing if we have the half quixels, or the quarter quixels even. It's going to be so cool. Image 2, so what I did is I changed my image to be the color quantization, or the domain coloring. So image 2 looked like this, which still looks really cool. I don't know why I like this as much as I do, but I think this is actually way cooler than I thought it would be. I'm actually really excited for this. And I shouldn't be this excited about coding a quilt, but somehow I'm incredibly excited for this. Okay, so we're gonna keep going. And again, our counting is wrong. For some reason, we're outputting, can you take a picture of a person or some animal? Yes, I can. LS, I have the perfect thing. Let me just, but I've got to go offline for just a second. So give me just a second. So I'll be back. I just have to do something that I don't want any of Twitch chat seeing. Sorry about that. You're going to like this image. I'm like 90% sure you're going to like this image, but I cannot show you what I am, like, I can't, yeah, just, I have to get it from an image bank that I don't want you guys to see. But I think you guys are going to like the image when you see it. If I can find the right image. Basically, my girlfriend sent me a photo of her dog, and I was like, that is perfect. Let's just get the... Oh, there's a photo of a cat. Let's also get that one. Wait. No, wait, back. Shoot. Oh, no. Oh, I hate this so much. Wait 1 second. You guys don't see what's happening, but I promise you, it is not... It's not great. Okay, let's just keep going. Yep. I'll be back in just a second, guys. Sorry for the ramblings here. What? Did I miss it? Oh, there it is. View image. And then the other one I want is... That's a nice dog picture, but I don't think that's the one I'm looking for. Oh, where's the dog picture? Oh, there it is. Perfect. Okay, so now I can delete this. And I can... I'm going to just save the images really quick, and then I'll be right back. Sorry about that, guys. Projects, Quiltify. Where is it? There it is. And we're just going to say dog.jpg. And now we have cat.jpg. Perfect. Okay, I'm back. Sorry about that. All right. So what do we have here? Does anyone know what he's coding? What are you coding? I'm literally making a quilt from images. 2% of the test cases pass. That's actually pretty good. Keep up the good work. Okay, so I'm gonna do dog is gonna be equal to load of dog.jpg. And cat is gonna be equal to load of cat.jpg. Okay, so now I'm gonna do im show of dog. So here's our dog picture. It's my girlfriend sent me a picture of her dog. And here is our cat picture. My sister sent me a picture of her cat. Well, rather, I took this picture of the cat. So we have a good picture of a cat, a good picture of a dog. Let's go. So the first thing we're gonna do is dog2 is gonna be equal to quantize of dog 8. Quiltify.quantize. Give it a second. I don't think this is going to be... It's not going to work very well, I think, for the cat and dog. But, you know, at least we have a cat and dog on stream. You know, that's not bad. Also, I hope my girlfriend doesn't watch this stream and think that I like, invaded privacy. Like, you guys didn't see any of the messenger chat. I'm pretty sure. Man, if only images weren't as high resolution anymore. Okay, so let's do im show of dog 2. I've got a feeling, yeah, it's just not very good because there, I mean, a dog's only so many colors, right? So let's go here and let's do cat 2 is going to be equal to cat 8. Although I could increase the number of colors. What made you get into Julia? I'll answer that in just a second. Old school dog emote. Yeah, she really likes Shiba. And I find it... It's not so weird, right? It's just that that's the stereotypical Japanese image. Or Japanese dog that you would like. You know, Shiba. So I find it a bit funny. So what made you get into Julia? I got into Julia because, quite frankly, my roommate was into Julia. And then, you know, I started programming a lot in it. And now it's my full-time job, basically coding in Julia. It's fine. I like the language. It's good. A bit of a cultish community, but, you know. Shiba is the Japanese version of a corgi? Maybe. So let's take a look at I'm show cat 2. And I like this image too. I think it's pretty good. I mean, admittedly, like the blue blanket is a bit much and the cat blends into the couch. But I think the same thing happened with the dog. Yeah. Okay, let's see what happens if we quick select that. So dog 3, wait, what was it? It was image 3 is equal to that. So dog 3 is going to be dog 2. And let's just see what it looks like. I am show dog 3. It's actually not so bad. That's a relative, like, if you just look at the dog itself, it's not bad. Oh. Again, not bad. That's like, it's really not bad at all. Need more neutral backgrounds. The paintings in the background of the dog picture are hogging all the colors. That could be true as well. Yeah, maybe. Shiba's, let's see. Let me take a look at the dog picture again. You're right, actually. I think it's just, we only have like 2 shades of blue. But yeah, you're right. And then like a shade of green in there. But I think the green's used over here as well. So, yeah. It's not bad. Like, it really is not that bad. Like, okay, it's obviously not a... Okay, hear me out. If I just took this giant dog's face and I made that a quilt, that wouldn't be bad. I think that'd be a pretty nice... Like, it wouldn't be bad at all. I mean, like, again, it's not great. It would still be funny. This is pretty good. I'm actually blown away at how good this is. Okay, anyway, let's oh, it's so cool though. I mean, like, anyway. Okay, let's see. So now we just have to figure out why we have black lines over here and see if we can get those half quixels and quarter quixels working. But yeah, then we're actually not so far off of where we want to be. So I'm actually going to save these images because I think they're actually kind of cool. So let's do I am just save of, I think I'm actually going to save cat2.jpg. Well, let's save it as PNG. Why not? Cat2. Does that work? Okay. And cat3. Okay. And now we're going to do dog3 and dog and dog2. So we have them to look at later if we want. Cool. Okay, so now we just have to figure out what's happening with those black lines on the borders, and then we have to have the half quixels and quarter quixels. But honestly, pretty excited about the progress with that. Like, I realized literally all we did was like turn things into pixel images, and I realized I'm sure there's plenty of software out there to do that already. I'm 100% sure there's a lot of software out there to do that. But you know what? I hadn't written any yet, so I'm still pretty happy with that. And again, I'm sure there's ways in which we could average it and do a whole bunch of other things to make it better. Like, it's still a lot of work to do, but you know, for a first attempt, it's not bad. Okay, so I need to do one more thing real quick before continuing. Right. Good. Okay, I'm happy with that. So we're gonna do VI source and quickslate, and let's see if we can figure out the indexing error first, and then after figuring out the indexing error, we can then go back to figure out figure out the rest of this. So let me take a look at the pride flag actually, or do I still have the pride flag? I might have actually removed it. I probably should have kept it. So let's do, because I thought the pride flag worked without having the black border, but all the rest of them have the black border. So if we do IM show the image, we get, I want image 3. Yeah, there's this black border over here. Okay, so what we want to do, paintings in the background, yeah, okay. Cool. Okay, so what we need to do is remove that border. I want to say that border is going to be of the size. Well, okay, let's just take a look. IMG3 is going to be this guy, and so let's do IMG3 of I guess we want to do colon. Let's do 3 minus end to end. And then I guess we're gonna do 3 minus end to end. See what happens there. 3, oh, end minus 3. Duh. Okay, so this is just a 9 by 9 array. Let's do n minus 8 and end minus 8. So this is all 0. Ah, it's not all zeros, actually. That is interesting. Let's do im show of image 3, this guy. Okay, that is a very small image. And there's exactly 1 pixel in that entire image. So the reason I wanted to grab the last 8 is because I was fairly certain that there was something going on where the last quixel was not being written to. But it seems to me like the last quixel is being written to. But only 7 out of 8 of the elements. So why would that be the case? Okay, well, let's just do our Quixelate here. And I think actually once we get the black border done, we might call it for today, and then we'll come back to do the half quixels and the full quixels. So let's do img3 is going to be equal to Quixelate. And so this is going to read into images 1920 by 1080, 1920 by 1080. Oh, is that why? Let me take a look at the size of dog. 1600 by 1200, size of cat. Interesting. These are probably all divisible 8. Yeah, okay. So because it's divisible by 8, we're actually running into an error where the last quixel is not being written to. If it wasn't divisible by 8, then it would be fine. So when we do dog 3, for example, here, the size of the output image is the same as the size of the input image, which is why we're actually running into an issue. You'd expect that to be the easy case, but apparently I'm just dumb. So, how do we fix this? So we have the length of the output is equal to 0. We have the start x and start y. And start x and start y are both 0 in this case. So we're going from 1 to quixel size. Let me output I and j in this case. I guess. So it's going to be I minus quixel size. Should be totally fine in this case. 2i, and then j minus quixel size is j. And then we're going to do out is going to be I minus start y minus quixel size. So in this case, it's going to be just I minus quixel size. To I minus start y minus 1. I see. We shouldn't need that minus 1, should we? Unless we... Okay, let me think about this. I think because we're iterating in groups of 8, it's going to count from 1... Let me just do this. So, for I is equal to 1 to 8 to 100. 1 second. Print line. I end here. Okay, so it goes 1 to 9. What is the length of 1 to 9? That should be 1 to 9. It should be 9. Right, but we want that to be 8. Okay, so this is the crux of the issue here, I think. We want to grab the next 8 elements. But when we set the quixel size to be 8, our indexing will actually grab the first 9 elements. So, I mean, yeah, if we could also start counting at 0. But it's going to run into the same issue, because if we do length from 0 to 8, it's still going to be 9 elements, right? It grabs that last element, and I think that's the issue here. Because it's grabbing 0 to 8, or 1 to 9, we're grabbing 1 extra element when we did that. So I tried to kind of fix that by doing this weird start y minus 1, start x minus 1. But clearly that's not right. So you're right. What we should be doing here is, instead of going from increments of quixel size, we should be going increments of quixel size minus 1, maybe? Maybe that's just what we do. We say quixel size is equal to quixel size minus 1. There is a much better way to do that. Okay, so now let's try image 3. Attempt to access. Okay, so that's going to be an issue, but let's just try dog 3 is equal to that. Error. Okay, so these are all erroring now. Attempt to access, and it's 1 to 8. Okay, good. So we're accessing those elements correctly. Wait, what's the issue here? Attempt to access 1596 by 11. Let me move this actually down here then. Try that again. Okay, that seemed to work, but it didn't seem to solve our issue. I think we still have a black border, it's just smaller now. Yeah, for some reason it's only 3 elements, I think. Okay, we're gonna have to think about this a bit. And then I believe image 3, we just won't work at all. Oh no, it did work. We just had a black. So what's image 3 gonna be then? Oh, right. Okay. What is your length size of image? 1920 by 1080 divided by 8. These are both divisible by 8 as well. Okay, we'll have to think about this. So there's a lot to figure out here. So yeah, this is definitely going to take a few minutes, and that's okay. We have a few minutes. Okay. So what are we indexing to and from here? I think the pixel size is going to be 8 pixels big. So we're going to say for I is going to be 1. We have to start counting at 1 plus some sort of start Y, which is going to be an offset. In fact, maybe I should call these offset Y and offset X. Okay, so it's going to be 1 plus some sort of offset in Y and some sort of offset in X. And then we're going to add in one of the pixel sizes, so plus 8. So this would mean ideally we start counting at 9. Okay, then we're going to go in increments of pixel size, and we're going to keep going until we hit the end of the image. Okay, so now what we're going to do is we're going to count. It is still 1 to 9, but I feel like it should be. Let's just do I minus 1 here, and J minus 1 here. And then down here we're going to do minus 1 again, and then again a minus 1. And let's just see what happens if we try this. Start X not defined. Oh, that's because these are now offset X and offset Y. Ah, we're so close. Like we have something that works. It's just getting the little details working. Start X. Where do I have start X? Okay. We're still getting the zeros, which isn't great. Unless black is one of the quantized colors, but I don't think that's the case. Let's do it with dog. Again, we're still getting zeros at the end there. Okay. So where is this failing at? It's going to be, so we have the color, which is going to be just the mode of image of I minus pixel size. So we start counting at 9. We go back to 8. So this is going to be 1 to 8. And then J is also going to be 1 to 8. The next iteration, we're going to be counting. Oh, we did a pixel size minus 1 up here. I think I'm going to remove that. That made it worse. I need to think about it. Okay, well, let's keep that in there. And then we're going to do. That doesn't make sense. Okay, 4. I is 1, 8, 100. We have 1, 9. The next one's going to be 9 to 17. What is the length of 9 to 17? That is going to be 9 again. Okay, but we should be counting. Okay, so 0, 8, 16, 24. That's what I was expecting to count. But it includes 0 and it includes 8. Right, so we just have to make sure we're not including that last element. Okay, that seems to make sense for me. Is this RuneScape? It is very far from RuneScape. I think. I'm not really sure, but I'm pretty sure it's relatively far from RuneScape. Okay, so that means the color is just going to be the mode of the image of I minus the pixel size. Yep, that'll bring you back. And then I minus 1. And then J is the pixel size. J minus pixel size to J minus 1. Then we have I. In this case, we don't have an offset X or an offset Y. So these should be the same elements, which is what's kind of getting me here. Let's just do dog 3 again. Okay. So we're reading in a 1080 by 1920. We're outputting a 1080 by 1920. And our offset and X and Y are both 0 in this case, right? So that means our color is going to be... I'm just going to output X and Y as well. Or I and J. I, new tab. J. J. I'm 9. Cool. I'm happy to see you here. That wasn't very helpful. It goes to 1080. So it's one element too short, I feel. 1905. 1905. This is because... Oh, what is going on here? It's counting in increments of 5 plus what is 13? 5 plus 8 is going to be 13. Okay, so it is going in increments of 8. Is this because we started counting at 1? So if I remove the 1 plus, it's going to fail, I think. Yeah, that definitely fails because it's... Oh, maybe we need the offset on the front end, not the back end. Okay, so let's do mode of 1 plus. There, and then 1 plus there. And then we're going to do it here and there. And we're going to do 1 plus here. And another 1 plus there. It is going to 1080 to 1920. We have all the colors. So let's do I am show dog 3. That's not a dog. Oops. Try that one again. So we should have a dog. Output goes to 1600, 1200. So if we do I am show dog 3, we should get an image of a dog without any black border. Perfect. Great. Okay. Seems to be working for images that are of the same size as their output image, which is fine. Okay. So now we want to try it for the pride flag, specifically because the pride flag was not the same size as the output array. So let's go ahead and comment that out there. And let's do img is going to be equal to pride.jpg. img2 is going to be equal to quiltify.quantize. Give it a second to do the quantization. And then we're going to try the pixelate as well. img3 is going to be that. Oh, did that work? I am show img3. Seems to have worked to me. Yeah, okay. There we go. Just to make sure I'm not doing something dumb here, 4.8 by 624, 415, 625. It looks like it's working to me. So I think, because I think the half square and the quarter squares actually might take some time to get right. I actually need to think about how we're going to do those steps. I'm actually going to probably close stream here for the day. So let me go ahead and add these in as to-dos. So we're going to do a quick to-do in here. Enable half and quarter squares. Write that. And let's go ahead and add that. Git add source. Well, let's do git status real quick. The project.toml was modified. Quantize backup.jl. I don't think I need that. Let's go to git add source and then quixelate. And also add the project.toml, git commit, -m, adding the ability to pixelate image with full quixel squares. Okay, I think that'll be fine for now. Git push upstream origin development. Again, I'm actually pretty excited with what we did today. Like, I realize maybe it's not as cool as fractals, right? We're still doing fractals later. Maybe it's not as cool as FFTs, but I think we're actually getting somewhere, and I'm actually really excited with that. So, yeah, I think we are good to go for now. Wait. And yeah, let's see who's live and who we want to raid at the end of stream. Let's see, we've got Zeldathon live doing Tabletop Simulator. Kimberly Lamb, let me see, doesn't she do... Oh, okay, I think she's the one that used to do Don't Starve mods and stuff. I thought that was quite cool. So how about we do Tayunui? We haven't raided him in a while. Let's go start that raid. Raid Tayunui. Okay. That is it for the day, guys. Thank you so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Simuleos. Should be tomorrow. Hopefully, we will finish up the Quiltify project with not only the allowing for half and quarter pixels, quixels, but also allowing for textures and stuff like that. And then after that, we will do something slightly different and then move on to FFTs and stuff starting on Monday. Pretty excited for that. So hopefully I will see you then. That's all for now, and I will see you next time. Bye, guys.